Ladies and gentlemen, imagine yourself walking away from a signal. The signal takes longer to reach you. You're about to learn how this fundamental truth will impact our worldview and our technological advancement. Welcome to the absolute motion sensing experiment. Let us now look into the situation. You can watch how source and observer move on after the signal is emitted. But this is what happens in real life. And it finds application these days. A limited technological application in circular coils, known as the Sagnac effect. However, recent research by Ryong Wang has identified this effect in isolated linear motion. His team effectively moved the source and observer in the same direction and measured how much longer the signal took. Such setup sadly cannot detect the motion of the platform. But in 1982, Paul Colin had already invented a simple setup to detect this motion. In 1991, De Witte employed the setup to detect a sine curve-like variation in the time of flight of a signal between stationary source and observer as the rotation of Earth turned the axis in space. But before we employ Colin's idea to build our experiment, let us form a hypothesis. What we have seen thus far suggests that electromagnetic waves are traveling disturbances in the fabric of space, through which we move at a speed of approximately 369,000 meters a second into direction Leo. Let's prove this. For this purpose, we will employ two hydrogen masers, a phase meter, and a baseline of 10 meters, aligned in the east-west direction. One of the masers will feed its frequency directly into the phase meter, and the other maser via a 10-meter distance. Whilst the Earth turns, we expect to see a variation in the time of flight of the signal along this 10-meter baseline, resulting in a phase shift. Aligning our equipment in the east-west direction allows us to detect the maximal difference the Earth's rotation can cause. By detecting the according component c of our velocity vector v into direction Leo, from which we can deduce the vector v. If our understanding is correct, rotating the experiment on the floor will yield an equal amplitudinal difference in the east-west direction, but at a higher frequency. Let us now look into the guts of what is happening at the two extrema, when the signal travels maximally into direction Leo, the picture on the left, or maximally out of direction Leo, the picture on the right. Again, you can see how source and observer move on after the signal has been emitted. What you see here is what happens in real life, because predictions based on this very model calculate the results measured by De Witte. However, to deliver a distinguishing proof of our hypothesis, we need to mount the experiment on a turnable axis, to, for example, return a null result when rotating along a plane perpendicular to Leo. This will not only fundamentally change our worldview, but it will also result in technology that will play a deciding role in the future of mankind in the universe, if mankind is to have one. Very basically, stage 3 will result in a prototype that autofocuses on and hence determines the direction of motion through the fabric via a simple program. This prototype will deliver a placeholder in equations to enable absolute synchronicity. This concept is directly employable in existing technology, but it also finds its future use when navigating empty space by solving the two spaceships on a rod problem. Ladies and gentlemen, thank you for your attention.